Yo, hello guys. I'm here writing the IC thread for the SharkPCB on GigHack. The Shark is complete. The board is it's complete as of now. Here it is. So it's completely wired and yeah. So it's definitely this should be the definite version. KiCad is showing that these pads, the pads for the microcontroller, has errors. Something along the lines of they're being too close, but I think this is some weird configuration that I have to deal with. But other than this, the whole thing should be quite nice. The board it's looking like this, so it's quite nice. It's a rather complete board in the sense that it has all the features you would expect from a basic board such as this. The only thing that I think I'm not adding in this version still, if I have time, I will add. If I have time, I will add it. Is the RGB underglow, right? So here in this row here, in the first row here, and maybe in this last should be some RGB underglow LEDs. Maybe I'll add them if I have the time, maybe not, but chances are that I'll add them next week. So also in this version, it's updated on the GitHub page, but the preview image is not updated still. I have to update it as soon as I can. I also have to add the logo here. The logo is in the front part, but not in the back part still. So what's the stream today for? The stream today for should be to talk to you guys about the project and what's this? And the overall idea behind the project and about the qualities of the PCB. So this PCB has some features that the PCBs generally don't have, like this, for example. These two guys here, they are the shield net, right? So they connect the cable shield to the ground on the PCB. These guys here, these guys here, they are an electrostatic discharge protection for the PCB. So I have seen, like in GigHack, what really caught my eye was on the M60 Rama M60 board, that some people, I don't mean a lot of people, but I think like 3 or 4 guys are having problem with this, that when the weather is kind of dry and they gather a lot of electrostatic, when they touch the board resets, or the LEDs keep on lighting, or it exhibits some kind of odd behavior whatsoever. So this should be the ESD net, and this hole here, it should be connected to the case, to the keyboard case. So you solder a little wire from here to the keyboard case. That's the idea. Also on the front part here, there is these guys. So what are these guys? These guys here, this is a fuse, and this is a Schottky diode. The idea here is to protect the keyboard from surge. So it says here, surge protection. So yeah, this diode, Schottky diode, it works kind of like a Zener diode in the sense that it regulates voltage when this surge happens, and the fuse, it protects from overcurrent. So this is the idea of these guys. Of course, all these features, they are optional. You don't have to use them yourself mandatorily, in the sense that if you don't want to use the surge protection, it's completely fine. You just don't solder the Schottky diode here, you leave it open, and you just short circuit these 2 pads of the fuse here. That's also nice. For the ESD protection, you can just solder nothing on there, and also there is the hard reset button, right? So in general, you have a hotkey combination in your keyboard to reset the firmware. so that you enter bootload mode, or I think it was DFU mode, to flash it. But I don't know. I think it's kind of weird that you don't have like a hard reset. If the firmware somehow goes haywire, you have this option. You can also short the pins, right? So if you reset, if you short, I think it's the pin 13 to the VCC, the which is exactly what this button here does. This push button does. The microprocessor, it resets what we like to call a hard reset, hardware hard reset. And that's it. So the board, it has full support for 3 basic layouts. So full grid if you want all the 48 keys. If you want just a 2U spacebar in the middle, or if you want a split spacebar, 2U and 2U, you can have all of those. What I want to do still is to make little markings for which one is which, so that it becomes easier for you to solder when you are looking at this here, because they all look the same. And I want to add like little text. This is the 2U spacebar, split spacebar, split spacebar. So when you are putting the switches and solder them, you don't incur in the problem to solder them wrong. The holes in the board, they are made to fit plank cases. Both there are 3, right? So the high pro, the mid pro, and the low pro. If I recall correctly, the high pro and the mid pro have these 3 holes here, making like a triangle shape, and the low pro has these 2 guys and the middle one. So the PCB should fit in in all 3 plank cases. It's not that I want to, and it's not that I want you to just change your plank PCB for this one, but I had to adopt a whole pattern. I had to adopt like the Daisy, the minivan, but since I have lots of contact with the guys at QMK and Jack, I have contact with Jack of OLKB, I thought it would be kind of nice to add plank support. And if you guys show interest in another type of hole configuration, I can also add it. Why not connect the ASD to the case through a blast standoff mounting hole? Okay, so you see, your proposition is nice. The big problem is that if you need to do that, when you do that, what I think what you mean is these guys here, they are grounded. The plated holes are grounded, and then you add the protection from these guys. The big problem is that the big problem with that is that by not having a special place with you see this net here, this ESD protection net here, it's not like just a short. It has a resistor. I think it was 10K. Let me check that. So no, it's 1 mega ohm and 4.7 nano. So what happens here is that in normal circumstances, this capacitor here, it kind of disappears, right? In the DC behavior, the capacitor is an infinite impedance. But when you are talking about high frequency surge, specifically surge, this capacitor here becomes a short circuit, so that the surge goes directly to the ground net. This is the idea. So I don't have. Why don't I do that? Blind Joker is telling, is because you need this net here, this special net, to properly direct the discharge. Was I clear? So yeah, so this is it. What I might change from this is I might add some RGB underglow somewhere around here, and I might put like the logo somewhere else, or just separate the shark image and the letters and put it somewhere else. But this is the finished project. Sorry. So I'm writing right now the Geek Hack IC thread, and well, ask me anything. And also the IC, and I'm adding it here. The IC is for the board. How can I say this? Semi built. So it will come something along the lines of this. So let me. It will have all the SMD components soldered in, right? So generally soldering the SMD stuff is not quite nice. It's here is the crystal, right? So the frequency crystal, which should be here, but it's not, because I think I don't have a 3D model associated with it in KiCad. And also there is the reset button, but these two will also come with the board that we are advertising on the IC. This should be the final look of the board. Also here there is the fuse and the diode for the surge protection. I think there's a typo in the for line. There. Typo in the fourth line. When opening the availability for the percent keyboard, I don't see the bear word here. Sorry, third. No, that's exactly the word. Bear with me. When you say bear with me, like you know, please understand me that I'm new to this. It's this exactly word here. It's not bear. Or is it? Bear with me means be patient with me. Bear with me, it's like bear, it's like the yep, I've been writing it wrong all my life. Also, it's bear like the animal bear. Okay, thank you, Joker. There it is. So the IC is for the semi-built PCB, and all you would have to do is soldering the diodes, the LEDs, and the resistors for the LEDs, and of course the switches. So I'm adjusting to this new. I just got a 40%, and I'm kind of adjusting to it. Here we go. So. So this is the board. All you would have to solder is the resistors. So see the RL resistors and the D diodes, which are the diodes for the switches and the resistors. for the LEDs and the LEDs themselves. Let me see if I have the 3D models for those here. 200 models. Yep, there we go. The resistors are kind of off axis somehow, but you get the idea. So this is the an example of a built board, right? And they are missing the LEDs here also. Let me put GHTF and the SMD also. SMD models. Also, I have some. We have the project includes not only the SharkPCB, the ortho layout as it is right now, but it also includes the Pro Micro version and the staggered version. What do I mean by that? And maybe a Pro Micro version of the staggered layout. So this is an ortho, right? Not everyone likes it. Not everyone can get used to it. Also, I will do a staggered layout, which I will call Hammerhead, and I will also have Pro Micro versions. What do I mean by Pro Micro versions? So, easy versions where all the components are THT. So you don't have any SMD stuff, and it's a much simpler board. The Pro Micro, it does not come soldered. The controller not come soldered, but there will be the profile somewhere around here in the right next or close to this connector footprint. There will be the footprint for a Pro Micro here, so that you can do a simpler board and test this by yourself and solder this all by yourself. I will also throw in the GitHub archives the plate file and the back plate file, so you can do something which we like to call skeleton board, much like the jerking. What is a skeleton board? So if you go here and type in jerking keyboard, so there we go. The jerking keyboard, it's like 3 plates, right? So as you can see here, he just has the back plate and the front plate and the back and the PCB, but the top and bottom plates. So there it is. So the jerking is this guy here, right? So it's a cheap keyboard, then you can use to test yourself. You do it with these standoffs, and then you just add rubber feet. All the parts, all the plates, the PCB, the front plate and the back plate are made out of FR4, which is the same material as the PCB. And this is used mainly for testing. So if you want to test a new these switches, if you want to test this layout, if you want to test pretty much a new keyboard, anything, you can just make a cheap keyboard, order it, and do it yourself at home. So as to test the profile, it's quite nice, really. So this is. I will also include a version like this one. So you have the front plate, the PCB, and the back plate, so that you can do it by yourself at home. Which will be, we are calling the THT version, right? So let me write this. The SharkPCB will also have a full THT version, which we have. Let me just link this. So again, what are the THT version? What is this THT version for? So you can test the layout. So many people are afraid of ordering like a fully fledged keyboard with a loop case and stuff, like the Daisy, like the minivan, like the Plank, because they fear they won't get used to the 40% or the ortho layout. So this should be a nice alternative for you to test these, to test it, so that you can see if you can get used to it, really. There we go. So let me take a picture of this so that I can add it to the IC. Let me take off these measurements. Here we go. I think I should add, I'm not happy with this. I think I should let the logo somewhere around here. Let me see if it gets better. Also, there is this little problem around here that some switches don't have here. Here we go. And let's see if I double the logo somewhere here. SharkPCB. Around here should be good. Or here, maybe here. Shark. Yeah, that looks kind of better with the Shark logo thingy. So let me take a print screen of this. I think that I forgot to add a print screen switch to my 40% layout. Goddamn. Oh, nice. How do I take a print screen here without the print screen, without the print screen key? Let's see. God damn it. Yeah, well, I think I'll add it later. Windows plus print. Yeah, I don't think I have a print key on my keyboard. I forgot to add it on the layout. I don't know if I even have it actually. I think I'll have to flash the keyboard with this key. Goddammit. But anyways, I think the yeah, the GNOME has this screenshot here. Current window. No window order. Yep, there it was. Save. And now from the back. Window take. There we go. The magic of GNOME. Yep, GNOME screenshot. I forgot GNOME has this amazing feature. GNOME all the way, man. GNOME all the way. I don't think KDE has this. I really prefer KDE myself. I don't know, man. I just didn't get used to KDE. I have used GNOME for such a long time. I mean, I have used Ubuntu for almost all my graduation, all my undergrad, and then in graduation I have jumped just like instantly to Arch. Sometimes I use LFS and Gentoo, but all of them are unknown. I just I just didn't get used to KDE. I don't know. I just figured GNOME has some better tools or yeah. Anyway, but KDE is not that bad at all. I mean, I'm not bashing into it. I just got used to GNOME myself. all kinds of WMs and distros before, but it can hit a checkbox for myself with Solus and KDE. Yeah, I think that since I'm not a programmer or a dev myself, I'm an engineer, and my need is for a fast interface, which is kind of easy. I spend my time writing simulation and math scripts on LaTeX and Python, so I don't have the need for some like super sophisticated interface and features. This fits quite nicely to me. It's simple, it's intuitive. I don't know, but I really see that the more specialized guys, they use KDE, Solus. I have heard it's a nice distro. I have also used like many distros in the past, Fedora, Red Hat, Mandriva, if you remember that. I think Mandriva doesn't exist anymore. I have also used Mint, and I think those were that. And Ubuntu, which I have used like for the majority of my undergrad. But Void and OpenBox also sound nice. I have never tried them, though I really hear nicely of them. I think I'll just delete the PhD master student. I don't want to sound arrogant. I like messing with Linux for fun, even though I'm not particularly proficient. Yeah, so Linux is this at least for me, it was this kind of passage ritual, in the sense that my work was really optimized with it, and I should have actually learned Linux better in undergrad, because now that I know it better, my work gets really fast, way faster than undergrad. But hey, living and learning. I have some. I had some interest to study Linux like hardcore also, but since it's not like in my research interests in engineering, if I was like a computer scientist or something like that, or a dev, maybe that would be nice. But I really don't need that, and I really don't have time to spend on studying hardcore. The rest of my time that I have, I am spending on developing keyboards. So. Yeah, but Arch, I use Arch right now, and it fits good. It's nice. Although you have to bear with it sometimes. You have to know the system yourself. It's quite nice. It works well. What I like about Arch is that it's something that QMK also has. Is this really well written and wide documentation. So when you have a problem, you don't need to go in forums. You can just go to the Arch wiki and read it read like this fully fledged page of information. It's really nice. I remember that I was able to fix some long-lasting problems with my printer with Arch Linux. In Windows, somehow I don't know why the drivers were not working, so the printer was not working. But I was able to work with I don't know how it's pronounced, CUPS, CUPS, the default driver interface for Linux, and I was able to make my printer work again. So yeah, Linux is it's quite nice thing to learn. But so in that sense, ArchWiki is absolutely the best. Yeah, it is. This documentation thing and the you know the knowledge jump you get when you read all the things and you contribute and read the forums and the wiki is just absurd. I mean, you can learn uh, the whole system from wikis. It's really nice. It's really nice, and it's what you know what hits me. What gets me is that it's well written. It's really nice to understand. It's not like it has the information in a nice way, and it is well maintained. It's quite nice. It's a nice distro. I recommend it to everyone that wants to try. Like everyone wants to try Linux, I recommend Ubuntu. And after the guy has learned Ubuntu and Linux quite nicely, I recommend Arch. Skipping like Fedora and Debian and all these distros, just go to Arch, and it's for me it's the ultimate experience from all the distros that I have that have tried. This is the best one for me, at least. So now I'm describing how the project is. So the design has some nice features, like ESD protection. ESD and search protection. I moved from Arch to Void as an experiment, but after a year I got tired of fighting with configurations and something important came up yet I didn't have it set up. So Void, you say Void, you fight with configurations when something important came up and I didn't have it set up. I had this problem with Arch in the first weeks that I was using it. I mean, I think everyone that used Arch had this problem with it. That when you have like what I like to call a bare bones system, like Arch, like Void, like LFS, like Gen2, that you must know your shit. You know, you must know your stuff. You must work on it. You must learn it. And you have to set the important things have to be set, otherwise you will be beaten up by your system. It will not work. It will. I had this episode that in this computer that I'm using right now, I dual boot. I have Arch and Windows because many applications that I need, like SolidWorks, Fusion, and some other CAD. And Word, you know, Microsoft Word and Microsoft Office in general, they don't work in Linux, so I have the Windows here. And then for some odd reason, Arch was not working, and I had this paper due to like the next day, and I was crazy on it, and I had to finish it on Overleaf in Windows. And when I came to see it, the problem is that I didn't add the fstab file on Arch, and then like the mounting point, the partition was not mounting, and then it was not working. And if you think about it, it's like a really dumb problem, because fstab should be set in installation, system install, but somehow I don't know, I forgot it, and that happened to me. So I don't know how about Void. Void is like Arch, but it's more Kiss. I've never tried it, though I have heard nice things about it. What do you mean when you say that it's more Kiss? Like, it's more simple? It's simpler? The tools it uses are simpler overall, like they need system, libc. Oh, I see. So what's your take on Void? Is it better? Is it worse than Arch? It was fun to use as an experiment for me, but I don't think it'd be good to use a 12 tray, I say. I thought I wouldn't really use Arch in that case either. Yeah, Arch, you see Arch, it works when you know how to use it. So if you update it constantly, if you keep monitoring your system, cleaning it, removing orphans, and reading the system journal, and all that kind of stuff. For me, Arch, it pays off, right? So you might think, yeah, that's quite a problem. That's quite a work you have there to read the system journals and some logs to see if something bad happens. But you see, this machine is running Arch for well over 2 years now, I think, a year and a half or something, and I have never reinstalled Arch. I have reinstalled it on the computer at the laboratory in the university, but that was because I changed the hard drive for an solid state drive. But other than that, it works real nice. I use it daily. I use it every day. It's my main tool of the trade. But I think that's a problem with Linux distros in general, that you have to know the distro nicely to use it every day as your main driver. Arch, these bare bones distributions, they have this problem that you have to know the system quite well to use them. But this is the fastest system that I have ever had here. It works flawlessly. It has never crashed on me. Python has never crashed. MATLAB has never crashed. Chrome has never crashed. It's just amazing how this works. Buttery smooth. At the same time, Ubuntu crashed like almost every day. I don't have to tell you about Windows, right? Fedora, I had some problems with it. Red Hat, I had some problems with it, and so on. source. The IC thread is meant to feedback, to have the feedback from the community so that you guys can point out problems and updates and problems, and you guys can deliver some I'm just really tired from work. You guys can give us some advices and some requests on the design and what you would like from the design. So the IC thread is not just about I like solos. I understand that, but personally I'd rather avoid doing the mainness at all because I don't particularly gain anything valuable. I like solos because now it's a curated ROM release. I still get mostly up-to-date packages, but it's meant to be user-friendly. If anything comes up wrong though, I can fix it. Yeah, if it works for you, then all power to you. I mean, I have the same relationship with Arch. Like, for me, it's really user-friendly. I don't have many problems with it. When some problems arrive, I can fix them. Again, I'm not like a hardcore user. I have not that many packages on it. All my packages, they are mathematical packages, Python packages, LaTeX packages, and maybe that's it. There's not much to it. So my system, it does not have many packages to be problematic to begin with. So maybe that's a reason why it works so flawless for me. I had not tried Solid though. I may take some time in the near future to test it. Today is the 11th. Yep. So what are the next steps? So the next steps are finish the THT design. So I didn't explain what the THT design is in the thread. I haven't added the Pro Micro thing, so let us see. Also, I forgot to mention that the THT version, it has an SMD component, which is the MOS, right? So the LED PWM MOS, which is this guy here. There we go. So this guy here, I haven't found yet a THT alternative to this guy here. This is the LED driver transistor. The jerking actually has these SMD guys, so maybe I'll just leave this guy in the first version. Maybe in another revision I can I can use a THT equivalent or something. So this is my idea here, maybe. Also, since the idea on the THT version is to be fully THT, I think in the Pro Micro, the THT version, we will not add the RGB underglow. If we find THT RGB that can be used, then maybe we will add. Mind you that the RGB underglow is not exactly the same RGB LEDs that the InSwitch uses. It's a different LED. It's an LED that has a microprocessor. It's not a microprocessor, it's like a controller chip imbued inside, but it's not the same as the RGB LED which is used in switches. Oh, nice. DC. God damn it. Yep. There we go. Done. Gondo is a bot confirmed. Yeah, it popped in the the IC popped in the Geek Hack bot in Discord, so the little sound popped. But yep, that's it. It is done. So anyway, Joker, do you have any more questions? Okay, nice. So I'll just wrap it up for today. I have seen some little problems with the writing here. I will correct those and take a nice bath and sleep because I'm tired AF. Okay. So any questions you have, just hit me up. See ya.